Alrighty, let's do problem number 5 in this wonderful problem set. So we have train A moving at its speed initially and train B moving at its speed initially. They hit, something happens, and they acquire final momenta that are different than their original, but the sum of their momentums is the same as the original sum. So total momentum is conserved. So here we have 17,000 kilogram car moving at 3.6, and we have this train B whose mass we don't know, moving in the opposite direction. And what ends up happening is that the car is moving at 0.6, the train A car, and train B is also moving at 0.6. So I'm going to do a little bit of algebra here. I'm going to use some distributive property stuff, and I'm sorry if this is hard for you to follow, but I like Algebra 1. It's easy for me to follow. So when I bring this to the other side, I'm going to end up getting 17,000 times 3.0 equals MB times 6.7. And so when I go ahead and solve, I'm going to get 17,000 times 3 divided by 6.7. And when I do that math, I'm going to end up getting 7,612 kilograms. All right. And you know what we're going to do? We're going to go ahead and actually finish the exam here. So an asteroid collides with the windshield of a car traveling down the highway, which experiences the greater change in momentum. The same. Why? Because FAB equals FBA by the third law. So that means the impulse is the same, and that means delta P is the same. Now, with this idea here, the velocity of the object doubles and the mass is 1/3 the original. What happens to the momentum? I thought I'd kind of make this a little bit more messy. So P equals mv. That's the old one. Now the new one is going to end up being P equals, let's double the velocity. We'll make it 2v, and let's make the mass 1/3 of what it is. So that ends up being 2/3 mv. So becomes 2/3. Now here we go. 40,000 Newton net force is exerted on a plane. We want to know the final speed of the plane. So this is an obnoxious one. We have Ft equals mv minus mv naught. So we're going to have 40,000 times 6 equals 96,000 times v minus 96,000 times 30. So we can actually go ahead and solve, and when we do that, the answer that we'll end up getting is 32.5 meters per second for the V. Now here, for part D, you know what? I'm actually going to leave that one blank. I heard some correct explanations, but I want you guys to see if you can figure that. So now this one here, to get the impulse, we're going to have Ft equals mv minus mv naught, and it's going to be 0.4 times 20 going back the opposite way I came, minus 0.4 times 20. So this actually ends up being 0.4 times negative 40, which works out to be 16 Newton seconds. So that is actually it for this part of the practice thing. We did the energy problems in class, which I hope you reviewed. And so I will go over those in the next video set.